Hello, good morning, students.
Good morning, sir.
Yeah, okay. Live start.
Okay, we are yesterday we had
Continue చేస్తారా?
Okay.
మిమ్మల్ని హోస్ట్ చేస్తా భయ్యా మరి. ఓకేనా?
Okay.
Once again. So we'll take your services again if needed. So Bhaiya, okay na?
Okay, thank you Anand, for giving
Thank you once again.
opportunity once again. Have a nice election season. All the best.
Right then, thank you.
Okay.
Right then, host
Madam,
it. Shall I leave then?
Okay.
Bhaiya, thank you once again. Carry on.
Hello students. Yesterday we had seen the preparation of carbonyl compounds. Today we will discuss about the different reactions. Yesterday we had seen even this one also. Aldehyde cyanide to ela react avutundi HCl. Okay. Em reaction jarugutayi cheppandi. What are the reactions of carbonyl compounds called as? Can anybody tell me? Hello? They are called as nucleophilic
ప్రతిక్షేపణ చర్యలు.
అడిషన్ రియాక్షన్. ఎందుకు న్యూక్లియోఫిలిక్ మాత్రమే పాల్గొంటాయి? ఇవన్నీ మనకు తెలియాలి బేసిక్స్. ఎందుకంటే రేపు ఎగ్జామ్ లో సడన్ గా ఏమైనా క్వశ్చన్స్ వచ్చినా కానీ న్యూక్లియోఫైల్ లోనే ఎందుకు పాల్గొంటాయి చెప్పండి. Why only nucleophilic addition? Because here the carbonyl group is polar. It is having partial negative charge. This is having partial positive charge. Carbon కి charge ఉంటుంది, partial positive charge. ఎందుకు వచ్చింది అట్లా? Because of the high electronegativity of oxygen. Okay, oxygen is more electronegative. కాబట్టి ఈ cyanide will attack which position? Carbonyl carbon only. Okay, followed by this one. This first step is nothing but simple addition reaction. All it is being unsaturated, it undergoes addition reaction. అంతే కదా, పై బంధం ఉన్నందువలన సంకరణ చర్యల్లో పాల్గొంటుంది. అదేవిధంగా న్యూక్లియోఫిలిక్ సంకరణ చర్యల్లోనే ఎందుకు పాల్గొంటుందంటే ఇక్కడ కార్బన్ కు పాక్షిక ధనావేశం ఉంది, అందుకే ఇవన్నీ కూడా ఆ చర్యలే అని చెప్పొచ్చు. HCl. ఓకే, హైడ్రోజన్ సైనైడ్. ఈవెన్ మనం కిలియాని ఫిషర్ సింథసిస్ లో కూడా ఈ హైడ్రోజన్ సైనైడ్ తీసుకుంటాం. దాన్ని బట్టి మనము ఓకే yesterday we had seen all these examples also. HCl తో ఎలా రియాక్ట్ అవుతుందని. Cyanide ion H plus followed by protonation takes place. Cyanohydrin, దీన్ని cyanohydrin అని పిలుస్తాం. ఓకే, అడిషన్ ఆఫ్ అసిటలైడ్. ఓకే, జనరల్ గా మనము అసిటలైడ్ అంటే ద సాల్ట్ విత్ అసిటలిన్, సోడియం అసిటలైడ్. ఇట్ ఈస్ కాల్డ్ యాజ్ సోడమైడ్. సోడమైడ్ తో రియాక్ట్ అయితే sodium will form this form a salt. Why? Because okay, we had seen acetylene is having, what is the nature of acetylene? Is it acidic or basic? Acetylene is acidic in nature. Okay, acetylene is acidic. Am I correct or not? Why it is acid? Important ఇవన్నీ. ఆల్కేన్ ఆల్కైన్లలో దేనికి ఆమ్ల స్వభావం ఉంటుంది? హలో, ఓకే, ఇట్ ఈస్ ఫర్ acetylene only. Why? Because it is sp hybridized. sp సంకరీకరణ చెందడం వలన దీనికి ఆమ్ల స్వభావం ఉంటుంది, సోడియం అస్టలైడ్ ఏర్పడుతుంది. ఈ సోడియం అస్టలైడ్ మన అగైన్ ఇక్కడ నెగటివ్ ఛార్జ్ ఏర్పడ్డది చూడండి. దిస్ పార్ట్ అనయానిక్ పార్ట్. This anionic part can attack our carbonyl carbon. Again, it is nothing but what type of reaction it is? Nucleophilic addition reaction. Okay, then followed by hydrolysis. That is, what is the use of this reaction? We can extend the chain extension. Okay, we can extend the chain of the reaction. Then mechanism. Just now I told you that it is going to attack on this one. Salt is formed, hydrolysis. Okay, enolate, double bond to enol antam, inolate. Okay, why? Because it is forming triple bond. Then hydrolysis of the salt will give this one, that is respective alcohol, O minus Na. Sodium bisulfite. ఇక్కడ చూడండి, సోడియం బైసల్ఫైట్ ఇక్కడ నేర్చుకోవాల్సింది ఏంటంటే Na ప్లస్ H minus, okay, SO3 minus 2.
Yes, sir.
Okay, HSO3, H plus, sorry, Na plus H plus. SO3 is minus 2. Okay, which one will going to attack first? SO3 minus 2 is the nucleophile. This will attack on this one. Then followed by SO3, H hydrogen will attack on this one later, fast step. This is the fastest step. Whereas first one is slow step. This fast jarugutundi, this slow ga jarugutundi. Okay, sodium bisulfite adduct antam then. Okay, it is called as adduct. Okay, NaHSO3, HSO3 minus, SO3 minus will attack, followed by carbonyl anionic oxygen bisulfite ion. Okay, Reformitsky reaction. What is Reformitsky reaction? Here it is going to form, that is alpha haloester. Alpha haloester will react with our carbonyl compound to form, finally this addition compound is formed. Okay, what is alpha haloester? This carbon is called as alpha carbon. Am I correct or not? It is alpha carbon and vilista. Endukante this is the main functional group, that is ester functional group. This is called as alpha haloester. Reacts with zinc. Zinc bromide is formed. Okay, what is the use of this one? It stabilizes the anion. Anion is stabilized. Why? Because we can, that is negative charge is formed. It is negative carbon and a nucleophilic center ఏర్పడ్డది ఇక్కడ. Now this nucleophile can attack, okay, or else it undergoes tautomerism to form enolate. This enolate will form an adduct with our carbonyl compound, which on hydrolysis, okay, are you following? Reformitsky reaction lo, what is the reagent? Zinc ether. What is the reactant? Alpha haloester. Alpha haloester is going to react with carbonyl compound in the presence of zinc. Okay, zinc సమక్షంలో జరుగుతుంది. Okay, this on acid hydrolysis will give, that is ester. Ester is formed, an addition adduct is formed. Okay, we are removing this ZnBr, zinc bromide is removed and it is converted into OH. OH laga maripotundi. Then another one is addition of water. We can add water, okay, directly, fast and faster. That is diol is formed. Diol is formed. Okay, last class we had seen about acetal formation. If ROH is taken, that is, it is going to form ROR. For this, what is the reason for this one? This is mainly because we can protect this one. Okay, there is no double bond here. See here, double bond O, double bond OH, yes. This is the product form. Product is this one. Diol is formed. Gem diol. It is called as gem diol. On a hydrolysis, gem diol is formed. Okay, try to follow this reaction. Then second type of addition reactions. Earlier, HCN, sodium bisulfite or Reformitsky reaction. What is happening there? Just we are adding the reagent. Whereas here, especially amino derivatives or amine, what is going to happen is here addition followed by removal of water takes place. Such reactions are called as condensation reactions. Addition is followed by elimination of water. Okay, when R is equal to H, it is aldoxine. Okay, everybody knows, I think, NH2. Ikkada automatically NH2OH, NHOH. If you see the mechanism also, nucleophilic attack of the reagent takes place. First of all, enolization. In this enolization, after enol formation, cation formation takes place. Now, this lone electron pair containing nitrogen will attack on this carbonyl, that is carbocation, and followed by protonation. Protonation also takes place. Okay, just simple గా రాయొచ్చు ఇది. ఇప్పుడు C double bond O is there. C double bond O is our carbonyl compound plus NH2 containing some group. Either it can be some group, that is, it can be G can be either NH2 or NH2OH or OH, it can be even OH or semicarbazole. We will see a number of examples. In the first step, what happens here? It is going to attack on this carbonyl carbon. Okay, it is shifted. And finally, it is forming CO minus. That is this hydrogen that is present here will be rearranged to form NHG like this. An addition compound is formed. NHG addition compound is formed, which later on this OH and this hydrogen both are going to lose this water molecule. This OH and this hydrogen are going to lose this water molecule, and finally C double bond N is formed. Okay, C double bond N, G can be anything. Okay, that is these are called as condensed product is formed. Okay, they are called as C double bond N containing compounds are called as shift bases. Okay, they are called as shift bases, my dear students. Okay, I think you had understood this one. They are nothing but shift bases are formed. Then reactions by hydride transfer. Hydride, we had seen this one earlier in alcohols also. That is hydride, they are nothing but reducing agents. Lithium aluminum hydride. I told you on that class that this lithium aluminum hydride, sodium borohydride, comparative study we did in alcohols. This lithium aluminum hydride is highly reactive. So in order to make it less reactive, what we have to do? We have to remove 3 hydrogens and convert it into mild, that is by adding ethoxide. Only 1 hydrogen, so that what is the use of this one? Carbonyl compounds, that is reducing agents, is converted into mild. Okay, CO moiety such as we can convert. Aluminum isopropoxide also reduces to bihydride. Cannizzaro reaction also involves hydride transfer. Cannizzaro reaction low important step is hydride transfer. Opanier oxidation low, Opanier oxidation. Aluminum isopropoxide when used, it is called as Opanier oxidation. Here also, what is the main important step? Hydride transfer. Many number of times this question will be asked. Hydride transfer jarugute emainata akkada reduction takes place. Lithium aluminum hydride and aldehyde is converted. I had given a table in alcohols also. Ketone to a secondary alcohol, carboxylic acid to primary alcohol, everything ultimate reduced product, carboxylic acid to alcohol. In the middle there is a stage. What is that? Okay, that is the carbonyl compound is not formed directly, it is going to alcohol, ester to alcohol, amide to amine. CONH2 is called as amide, nitro compound to amine, acid halide to alcohol. Okay, these are the important examples, that is aldehyde acetone finally converted into alcohol like this. This is the intermediate formed. This is the intermediate that is formed. That is hydrogens, 4 hydrogens are removed and replaced by this molecule. Okay, they are replaced by aldehyde. Okay, four hydrogens, therefore 4 molecules of aldehyde are required. Okay, that is about the reaction. We had seen this reaction number of times. This is, what is this one? Methyl benzoate ester. Ester also converted into alcohol like this. Okay, my dear student, try to understand this one. We had seen this lithium aluminum hydride mechanism is also had explained. That is, it forms an adduct like this, and later on this aluminum will be attached to this oxygen, whereas hydride shift is taking place from this alane, that is aluminum. We are having 4 hydrogens, one of the hydrogen is shifted to this carbonyl carbon. Then reduction by lithium aluminum hydride, that is, it is not going to disturb the double bond. Double bond is not at all disturbed. That is most important. Then Wolff-Kishner reduction. What is Wolff-Kishner reduction? Here double bond, C double bond O is converted into CH2. Wherever you are having this C double bond O, just remove it and replace it with CH2. That is saturated carbon. Yes, carbonyl carbon is converted into aliphatic carbon. This is called a Wolff-Kishner reduction. Or else, what is the reagent? Hydrazine HCl, NH2, 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 and HCl. In the presence of acid medium, hydrazine is going to form, that is a condensed product. Hydrazone is formed. This hydrazone in the presence of base is finally converted into the saturated carbon. Okay, that is about Wolff-Kishner reduction. If you see the mechanism of the reaction, okay, that is here an adduct is formed, same as that of we had seen earlier in the beginning of this class about how this amine, that is nitrogen compounds, there is a lone pair, it is going to attack on this one and OH is formed here. Later on, in the presence of base, one after one of this hydrogen is removed, and finally that is we are going to get CH2. Why? Because there are 2 hydrogens, therefore 2 moles of this base is required, and finally nitrogen is removed as it is. Okay, first time oka hydrogen potundi, appudu minus charge vachindi. Okay, then another hydrogen is also removed by base. What is the base property or function? Is to just abstract or remove this hydrogen. Okay, and it is going to give this saturated compound. Saturated compound is prepared finally. Then another one is polymerization reactions of carbonyl compounds. Please, direct questions will come from here. Acetone in the presence of concentrated sulfuric acid is going to give mesitylene. Acetone, constant, gurtunchukovali, direct questions vasthayi. Polymerization reaction. Acetone is giving 1,3,5 trimethyl benzene is called as mesitylene. Formaldehyde in the presence of base, that is barium hydroxide, giving hexose, formose, or metaldehyde, hexose. This is the structure of metaldehyde. Formaldehyde, this is a form from same base. If you use acetaldehyde, this product is from acetaldehyde. Okay, acetaldehyde is giving trioxane. That is, formaldehyde is giving trioxane, whereas acetaldehyde is giving, sorry, this acetaldehyde is giving paraldehyde. See here, formaldehyde. మనకు ఇంపార్టెంట్ రియాక్షన్స్ ఉన్నాయి ఇక్కడ. ఇది డైరెక్ట్ క్వశ్చన్స్ వస్తాయి మై డియర్ స్టూడెంట్. వన్ ఈజ్ ఫార్మాల్డిహైడ్, గుర్తుంచుకోండి. ఫార్మాల్డిహైడ్ బేరియం హైడ్రాక్సైడ్ బేస్ లో హెక్సోజ్ వస్తుంది. హెక్సోజ్ షుగర్, is formed. Then metaldehyde is formed from acetaldehyde polymerization is giving metaldehyde. Any moles kavali ikkada? 4 moles are required. Polymerization means monomers are going to combine to give polymers. Then n moles of formaldehyde gives paraformaldehyde. N moles of formaldehyde will give paraformaldehyde. Then formaldehyde in the presence of concentrated sulfuric acid, more number of this one polyoxymethylene is formed. Formaldehyde, room temperature, trioxymethylene. Okay, trioxymethylene, CH2O taken thrice. What is trioxane? This is trioxane or trioxymethylene, otherwise called a trioxymethylene. Paraldehyde. When paraldehyde concentrated sulfuric acid gives paraldehyde. If you at room temperature it gives metaldehyde. Okay, metaldehyde. Concentrated sulfuric acid is giving metaldehyde as well as paraldehyde. But at room temperature we have to take. Very high temperature, I think distilled, it is giving paraldehyde. At room temperature, 0 degrees centigrade. At 273 Kelvin means 0 degrees centigrade, it is giving metaldehyde. Okay, all these reactions are also important. Polymerization of acetaldehyde, polymerization of formaldehyde. Many number of times direct questions will come. In the beginning also earlier we had seen about Reformitsky reaction. There is a mechanism. Okay, what is the condition? Alpha bromo ester is required in the presence of zinc. Tischenko reaction. What happens here? 2 moles of aldehyde, 1 mole is converted into, what is the reagent here? Aluminium ethoxide. It is going to form an ester. Ester is formed. Tischenko reaction lo ester ఏర్పడుతుంది అని గుర్తుంచుకోండి. Reagent ఏంటిది? Aluminium ethoxide. ఇటువంటి రియాక్షన్ ఒపానియర్ ఆక్సిడేషన్, కానీ అక్కడ ఏంటిది? అల్యూమినియం ఐసోప్రోపాక్సైడ్ ఇస్ ద రియేజెంట్. టిశ్చెంకోలో అల్యూమినియం ethoxide is the reagent. Okay, Claisen-Schmidt reaction, condensation between aromatic aldehyde or ketone and aliphatic aldehyde or ketone. Aliphatic aldehyde and aromatic aldehyde is giving an adduct is formed like this. Okay, that is alpha beta unsaturated aldehyde is formed. Claisen-Schmidt reaction, it is called as Claisen-Schmidt reaction. Then aldol condensation. In the presence of dilute, very important is aldol condensation. Okay, in the presence of dilute base or dilute acid, 2 molecules of an aldehyde or ketone may continue to form beta hydroxy aldehyde or beta hydroxy ketone. It is only the alpha hydrogen atoms which are involved in aldol condensation. Okay, it is an example of the third order reaction. These are very important. This one, which one? Can anybody tell me which one will undergo aldol condensation here? Hello students, ఏది ఆల్డాల్ కండెన్సేషన్ లో పాల్గొంటుంది? ఆల్ఫా హైడ్రోజన్ ఉన్నవే ఆల్డాల్ కండెన్సేషన్ లో పాల్గొంటాయి. ఇది ఆల్ఫా హైడ్రోజన్ ఉన్నాయి, ఎన్ని ఉన్నాయి? ఇక్కడ 2 ఉన్నాయి, ఇక్కడ 2 ఉన్నాయి, ఇక్కడ ఉన్నాయి. ఇది కూడా ఆల్ఫా హైడ్రోజన్స్ ఉన్నాయి, ఇక్కడ కూడా ఉన్నాయి, అన్నిట్లో ఉన్నాయి. ఇటు చూడండి, ఫార్మాల్డిహైడ్ లో ఉందా? ఫార్మాల్డిహైడ్ లో ఆల్ఫా హైడ్రోజన్ ఈజ్ ఇట్ దేర్ ఆర్ నాట్?
No sir.
నో. క్లోరాల్ లో లేదు. ఓకే, బెంజోఫినోన్ లో లేదు, బెంజాల్డిహైడ్ లో లేదు. ఓకే, ఇవన్నీ నో aldol condensation, whereas this will undergo aldol condensation. This will undergo aldol condensation. Why? Because here there is no alpha hydrogen, but in the presence of base, okay, that is about aldol condensation. The presence of base, what happens here? Hydrogen is removed, carbanion is formed. Everybody knows alpha beta unsaturated compound is prepared. Okay, మనం చెక్ చేసుకోవాలి, బేస్ ఉంది మనకి ఇక్కడ ఆల్ఫా హైడ్రోజన్ ఉంటే వెంటనే అది ఇక్కడ మనకు ఆల్ఫా బీటా అన్సాచురేటెడ్ కాంపౌండ్ వస్తుంది, అట్లా చూడాలి. ఓకే, in the presence of is more acidic than alpha hydrogen. ఎందుకు alpha hydrogen లోనే మనకి ఇక్కడ రియాక్షన్ జరుగుతుందంటే alpha hydrogen is more acidic. ఎందుకు more acidic? Can anybody tell me why alpha hydrogen is more acidic? Because C double bond O ఉంటుంది పక్కనే. అయితే ఏమవుతుంది C double bond O లో ఏంటిది స్పెషల్? ఇక్కడ CH3 3 hydrogens are there. Okay, here what happens here? Slowly the electrons are removed or attracted by this oxygen. As a result, what happens? It becomes more acidic. Hydrogens are becoming more acidic. Ikkada CH3 CHO, it is having 3 alpha hydrogens, whereas here 2 alpha hydrogens are there. Okay, it is mainly because of the acidic nature of hydrogens. It is alpha hydrogen of ketone that it is called a crossed aldol condensation. Okay, that is ketone is there in enol form. And here aldehyde. This CH2 is going to attack enolate. Okay, what I want to tell is which is going to attack when aldehyde and ketone are condensed. Alpha hydrogen of aldehyde is not react, that is will not participate in the, whereas it is the methylene of the ketone that is going to participate. Methylene ఇక్కడ బాగా కలర్ గా చూపించింది చూడండి. ఇక్కడ ఇది ఇక్కడ కీటోన్ పార్ట్, ఇది ఆల్డిహైడ్ పార్ట్. ఆల్డిహైడ్ లో కూడా మనకు మిథిలేన్ ఉంటాయి, ఉన్నా సరే ఇవి మాత్రం పార్టిసిపేట్ కావు, అది గుర్తుంచుకోవాలి. విచ్ పార్ట్ is going to participate? Okay, I think everybody knows aldol condensation, but technically there are some questions that can be asked. Okay, in the presence of base, the reaction takes place, condensation, everybody knows this. Internal aldol condensation is an example within the molecule only. Okay, crossed aldol condensation. Okay, crossed aldol condensation is also taking place. There is one methylene group, methyl group that is going to attack. When two different molecules are participating in an aldol condensation, it is called a crossed aldol condensation. Okay, if alpha hydrogens are there, it undergoes alpha, that is aldol condensation. If there is no alpha hydrogen, okay, just now we had seen many number of examples without alpha hydrogen. Okay, all these molecules below the line will undergo which reaction in the presence of base? No alpha hydrogen, they undergo Cannizzaro reaction. Aldehydes without alpha hydrogens. One molecule is reduced to alcohol, another molecule is reduced, oxidized to carboxylic acid. When the same molecule is undergoing two types of reaction, one is oxidation, two opposing reactions they are. One is oxidation, another one is reduction. They are called as disproportionation reaction. It is called a disproportionation reaction. Hydride transfer is very important. In the Cannizzaro reaction, hydride transfer takes place. Okay, formaldehyde. It is one molecule is getting converted, reduced, that is methanol. Another one is oxidized to form formic acid, which later converts into sodium formate. Okay, benzaldehyde, no alpha hydrogen in the presence of base gives benzyl alcohol and sodium benzoate. Nucleophilic attack. Okay, see here the mechanism. Okay, that is here. Nucleophilic attack on electron deficient atom of another aldehyde molecule. The species directly transfers hydride ion to the electron deficient carbonyl carbon atom of another aldehyde. Rapid proton exchange. Alkoxide ion. Okay. Here there are two molecules. Of these two molecules, in the presence of base, what is happening? This is formed. Okay, that is anion is formed. What is the property of our carbonyl compound? This anion now is going to transfer this hydrogen directly. Hydrogen is transferred. Direct transfer. Okay. Directly it is transferred and it is giving alkoxide and carboxylic acid. Later on, in the next step, this hydrogen is shifted. Acidic hydrogen is shifted to this anion. That is forming alcohol as well as carboxylate anion is formed. Carboxylate anion is formed. Any doubt here? Hydrogen direct transfer. ఇప్పుడు మన ఖాతాల్లో డబ్బులు పడడం ఏంటిది? డైరెక్ట్ ట్రాన్స్ఫర్. ఒకప్పుడు రోడ్లు వేసేది అన్ని వేసేది కానీ ఇప్పుడు డైరెక్ట్ డబ్బులు ఇస్తున్నారు కదా వివిధ పథకాల ద్వారా. దిస్ కాల్డ్ డైరెక్ట్ ట్రాన్స్ఫర్. Here also it is direct transfer. Okay, direct hydrogen transfer. Hydride shift, H minus is shifted. Intramolecular, అంటే within the molecule. దీన్ని ఏమంటాం చెప్పండి, ఎవరైనా చెప్పండి దీని పేరు? గ్లయాక్సాల్. గ్లయాక్సాల్లో ఒక భాగమేమో రెండు తలకాయల పాము లెక్క. ఓకే, ఇక్కడ ఒక ఆల్డిహైడ్ ఏమో ఆల్కహాల్ లాగా మారింది, ఇంకొక ఆల్డిహైడ్ గ్రూప్ ఏమో కార్బాక్సిలిక్ యాసిడ్ లాగా మారింది. ఓకే, ఇక్కడ కూడా చూడండి, ఒకటేమో కార్బాక్సిలిక్ యాసిడ్, ఇంకొకటేమో ఓకే ఆల్కహాల్ లాగా మారుతుంది. ఏం కావాలి మనకు? కాన్సన్ట్రేటెడ్ సోడియం హైడ్రాక్సైడ్ బేస్ కావాలి. ఓకే, దట్ ఈస్ అబౌట్ క్యానిజరో రియాక్షన్. విట్టిగ్ రియాక్షన్. The reagents are ఏమేమి రియేజెంట్? ముందు రియాక్షన్ చూడండి, ఇది విట్టిగ్ రియాక్షన్. డబుల్ బాండ్ ఓ తీసివేస్తున్నాం, డైరెక్ట్ గా మనం తీసేస్తాం. ఫార్మింగ్ ఆల్కీన్. ఇక్కడ ఎన్ని కార్బన్ ఉన్నాయి చెప్పండి? ఫస్ట్ దాంట్లో వీఆర్ హ్యావింగ్ హౌ మెనీ కార్బన్స్? 1 carbon. Here how many carbons are there? 2 carbons. Means what are we doing? We are extending the chain. చైన్ ఎక్స్టెండ్ చేయడము సింథసిస్ చాలా ముఖ్యం ఆర్గానిక్ సింథసిస్ లో, అంతే కదా. కార్బన్ల సంఖ్య పెంచుతున్నామంటే ఇటువంటి రియాక్షన్ చాలా ఇంపార్టెంట్. విట్టిగ్ రియాక్షన్ ఏం జరుగుతుందో చూడండి. మనం రియాక్టెంట్స్ ప్రొడక్ట్స్ గమనించాలి, ఆర్గానిక్ కెమిస్ట్రీలో అదే చేయాలి. యూ హ్యావ్ టు కంపేర్ ద రియాక్టెంట్స్ అండ్ ప్రొడక్ట్స్ అండ్ లెర్న్ స్లోలీ. ప్రాక్టీస్. ఇక్కడ లాంగ్వేజ్ తో సంబంధం లేదు, ప్రాక్టీస్ చేయాలి. ఏం అవుతుంది, ఏం మార్పులు వస్తున్నాయి మీరు గమనిస్తే మీకు ఆర్గానిక్ కెమిస్ట్రీ వచ్చినట్టే. ఓకే ఓకే ఇలాయిడ్ ఈస్ ఫార్మ్డ్. న్యూక్లియోఫిలిక్ అటాక్ by the anionic carbon to yield electron deficient to yield butane in an intermediate. దీన్ని ఇంటర్మీడియట్ అంటాం. ఇది ఒక సైక్లిక్ 4-member cycle. Okay, butane transition state is formed, which later on undergoes strong that is rearrangement to form this alkene. Wittig reaction of product into the alkene. Okay, another one is, this is called as ylide. The ylide and will stop triphenyl phosphine, and this compound is called as ylide. Why? Because it is having plus charge and minus charge. Okay, zwitterion laga okka dantlo plus charge minus charge untai. Ylide and will stop ylide. Okay, ఎట్లా వస్తుంది ఇది? దట్ ఈస్ ఇట్ ఈస్ ఫార్మింగ్ PPH3 డబుల్ బాండ్ C. MPV reduction. We had seen opanier oxidation for which one alcohols are converted into carbonyl compounds. Reverse reaction of opanier oxidation. The conversion of carbonyl compound by the action of aluminium isopropoxide. Aluminium isopropoxide is this one. Okay, it gives aldehyde. This is the reagent, the reactant, and finally it is giving alcohol is formed. It is a reversible reaction, my dear students. That is most important. We have seen this reaction number of times. Okay, that is here. Important step is again hydride is getting transferred. Hydride transfer taking place. This hydrogen or hydride is shifted onto this part. Okay, that is called as hydride transfer. Hydride transfer takes place here. Hydride transfer is taking place. That is most important. The reverse of MPV reduction is called as, what is it called as? Opanier oxidation. Okay, Opanier oxidation also the same reaction. Okay, this is called as Opanier oxidation. Here H should be there. Okay, that is about, we had seen MPV reduction as well as Opanier oxidation earlier. Benzoin condensation is different. Benzoin condensation, what is the reagent? Potassium cyanide. Very number of times it was asked. It is a property of only aromatic aldehydes. Aromatic aldehydes catalyzed by cyanide. Okay, it is catalyzed by cyanide. And what happens here? It is going to form benzoin. Benzaldehyde is converted into benzoin. Reactant products బాగా చూడండి, మెకానిజం కంటే కూడా ఇప్పుడు ఎంట్రన్స్ లో చూడాల్సింది ఇదే. ఓకే, ఇక్కడ కూడా ఏమవుతుందో చూద్దాం. మెకానిజం లో కూడా ఇంపార్టెంట్ స్టెప్ ఏంటో చూద్దాం. ఓకే, see here, cyanide is attacked and negative oxo anion is formed. Later on it is removed, cyanide. Okay, here in this way anion is formed. This anion nucleophilic species is formed which attacks on the carbonyl carbon. Okay, cyanide, the rapid proton transfer and rapid loss of cyanide ion takes place. This is the important step here. Proton transfer, this hydrogen of this one is transferred directly. Okay, proton is transferred. Earlier cases we had seen about hydride transfer, means H minus is transferred, whereas here proton transfer is very important step. Rapid proton transfer followed by the elimination of cyanide. Elimination of cyanide takes place to give benzoin. Is the important point గుర్తుంచుకోవాలి. ఎందులో ఇది benzoin condensation. How many moles are required? 2 moles of benzaldehyde are required. This is 1 mole, this is another mole. Okay, that is called a benzoin condensation. Why only cyanide is used? Because it is a better leaving group and stabilizes the anion. To stabilize the anion, this minus charge should be stabilized. Cyanide, we know that it is a highly electronegative. It attracts all the minus I affecting group. Therefore, it attracts and stabilizes the anion. Cyanide ఉన్నట్టయితే రియాక్షన్ లో, ఆర్గానిక్ కెమిస్ట్రీ లో సైనైడ్ రియేజెంట్ ఉంటే బెంజాయిన్ కండెన్సేషన్ ఎక్కువ అవకాశం. గుర్తుంచుకోవాలి, బెంజాయిన్ కండెన్సేషన్, ఆరోమాటిక్ ఆల్డిహైడ్లు మాత్రమే ఈ చర్యల్లో పాల్గొంటాయి. ఓకే, benzylic acid rearrangement. Perkin reaction. Here, what is Perkin reaction? The aldol type of condensation. Again, in aldol condensation లో కూడా మనకు ఇది లేకుంటే CH2 మైనస్ వచ్చేది. ఇప్పుడు కూడా CH2 మైనస్ వస్తుంది, దీనిపైన అటాక్ అవుతుంది. బెంజాల్డిహైడ్, aromatic aldehydes with an aliphatic acid anhydride. This is called as acidic anhydride తీసుకుంటున్నాం. In the presence of acetic acid to form cinnamic acid. PH, CH, double bond CH, COOH. Okay, cinnamic acid is formed. చూడండి ఇక్కడ again this acidic hydrogen is removed, which nucleophilic addition is giving the cyclic intermediate is formed, which later on converted into this cinnamic acid is formed. Try to understand the reaction. Reagents what are the reactants, what is the product, that is most important. Okay. Okay, my dear students, you practice this one. Chemistry should, without practice, you cannot get any one. I will share all the PPTs. Any
Sir, slides share చేయండి sir.
definitely అమ్మా.
Okay,
అర్థమైంది
sir.
ఏమన్నా నేర్చుకున్నట్టు అనిపిస్తుందా?
Yes, sir.
ఓకే, ప్రాక్టీస్ చేయకుంటే రాదు, volatile subject అంటాం. ఓకే, ఆల్ ద బెస్ట్. ఓకే, థ్యాంక్ యూ రమేష్ సార్ ఫర్ గివింగ్ మీ దిస్ ఆపర్చునిటీ. థ్యాంక్ యూ వన్ అండ్ ఆల్ ద బెస్ట్. ఓకే,
Thank you, sir.
Thank you, sir.